second-year graduate student from Institute of Electronics, National Yangming Jiaotong University, by Ambassador Zhang Qijia. And it's a great pleasure to introduce our lab and genetics research in this year's conference and committee. Our ambassador, Professor Zhang Qijia's academic journey is truly remarkable, and he holds advanced degree in electrical engineering, including bachelor, master, and PhD degree from National Jiaotong University at Taiwan. And his career path is also impressive. He started as a MediaTek manager at a department of OSP D1 from 2002 to 2003. In 2003, he returned back to the academia and became the professor in the electrical engineering department at NCTU. And then in 2007 to 2020, he became a technical consultant at Macronics. And in 2014 to 2017, he was a Deputy Director General in National Chip Implementation Center under NAR Labs at Taiwan. And by the way, his innovation motivated him to become to create a Wale technology in 2020. And he take a role on a co-founder and a CTO. And Wale technology is a storage class memory control ASIC technology company, and with a headquarters in the San Jose, California, and the R&D teams in Taiwan, Hsinchu. And his research is interesting in algorithm and VLSI architecture in signal processing, especially the error correction codes, crypto system, and artificial intelligence. And he published more than 140 IEEE journals and conference papers, including 5 in the IEEE International Solid-State Circuit Conference and 3 in the Symposium on VLSI Circuit. And he also published more than 70 patents in US and Taiwan. And this is our lab. Our lab is called OASIS Lab, and it stands for Optimized Application Specific Integration System Lab, and it established in February 2003. And currently, there are 1 PhD and 13 master students. And this is our year-end party. And this is me in the middle, and this is our teacher. And we have 3 research teams. The Ocean group is for overcome error and noise. And the STAR group is for secure trust and reliability. And the ML group is for machine learning. And our lab recent graduate in the past 3 years went to the well-known IC design house and EDA company like MediaTek, Novatech, and Synopsys. And let's start with our research introduction. And the first is our Ocean group. Ocean is short for overcome error and noise, and it focuses on implementation of channel coding, also known as the error correcting codes. Channel coding is used to protect digital data and prevent data loss during the transmission. And it is widely used in a storage device, such as power device, flash memory, storage class memory. And it can also apply in a communication system, such as cell phone, digital television, wireless local area network, ultra-wideband communications, 5th generation new radio, and beyond 5th generation communications. And our recent research includes LDPC decoder in SSD application, and a low latency error and erasure RS decoder. And the next is our STAR group. STAR is short for secure trust and reliability, and focus on the crypto system and hardware security, especially the architecture design and the crypto chip attack analysis. And crypto systems are a set of a protocol designed to secure communication. And there are various encryption and decryption algorithms to protect the security of the data during the transmission. And the main goal of the hardware security is to conduct security analysis and protect the crypto chips. And there are many types of the crypto system, like elliptic curve cryptography, authenticated encryption with associated data, cryptocurrency like Bitcoin, and post-quantum cryptography. And it can also use in the storage system like memory authentication, database, and storage. And our recent research includes general purpose ECC engine with a side-channel attack countermeasures. and a low latency SRP5 cryptography engine with a POP as root of trust. And the last one is our machine learning. Our machine learning group is focused on developing specific model using machine learning techniques for a wide range of the application. And machine learning is used to extract features from data and apply machine learning models. And our machine learning group research directions are highly diverse. For example, the speaker analysis, biomedical image segmentation, and semiconductor data analysis, and more. And our recent research include computer online speaker dialyzation, 3D MRI brain tumor segmentation, and PCB defect detection. And our machine learning group is eager to participate in the various AI application competition. In 2022, we participated in the AI Cup competition. We utilized the XGBoost ensemble learning to combine various SOTA models to classify the crops. And this is an application in agriculture. And in the same year, we participated in the Synopsys RL AIoT design contest. And it is a contest for embedded AI and AIoT. And we use the Synopsys ARC processor for the face verification on the edge device. And we combine and we integrate a hand pulse estimation to create a control-less control panel. And in this year, we took part in this competition once again. And we have implemented a smart analog gauge reader for traditional factories. And the introduction to our lab is over. And now I'm going to show you our machine learning group recent research. An end-to-end neural network with a clustering enhancement for computer online speaker dialyzation. So what is a speaker dialyzation? During a speech, human voice actually contains an amount of data. For example, the accent of a speaker, the language being spoken, the content of a speech, or even the emotion conveyed while speaking. All these tasks is aimed to extract some specific information from speech. One such task is speaker dialyzation, which is used to determine who spoke when. In Chinese, 谁在什么时候说话? And what is the difference between the speaker dialyzation and speaker recognition? Speaker dialyzation during a reissue with the multiple speaker in each speech utterance, and we want to separate the audio segment of different speakers. And speaker recognition dealing with only one speaker in each speech utterance, and we want to know who is speaking. And there are three main design challenges for a speaker dialyzation. The first challenge is a multiple speaker and flexible speaker. And the second challenge is speech overlap. And the last challenge is real-time processing. And this is our proposed model. And to achieve the real-time processing, we introduce a method called streaming rolling buffer. And this rolling buffer divides the long audio into small sequence, which sequentially fed into the model. And we do some preprocessing. In the first stage of the preprocessing, we use NewGAN for super resolution to enhance the audio quality. And in the second stage of the preprocessing, we use preemphasis. This process passes the audio through a high-pass filter to enhance a higher frequency. And next is our speaker dialyzation model. The end-to-end speaker segmentation models include three main components. SyncNet is for feature extraction. LSTM enables the model to learn the temporal dependency among the data. And the fully connected layer serves as the final classification layer. And because the number of speakers may increase over time, so we use incremental clustering to solve this issue. We map in the speaker embedding to represent speakers and decide if the existing speaker embedding include the existing cluster or not. And at a post-processing stage, we select the threshold of the speaker dialyzation. And we can get a final result of the speaker dialyzation in real time. And here is our demo video. And in this video, we will demonstrate our proposed model applied to a popular podcast in Taiwan, bilingual news. At the bottom left, we'll show the result of a real-time speaker dialization. And the red line stands for the female host, and the blue line stands for the male host. Here will show the result. So this is pure music. And this is female host.
百灵果 News, the free international news podcast in the Trans-speaking world.
我是凯莉，
This is Ken.
我们会用百灵果双语的方式与大家聊聊世界各地有趣的新闻。
We'll be using both English and Mandarin to talk about interesting news happening around the
因
world.
为讲太快了吧？
很急啊！
因为我刚把范姐赶走，好爽哦！
不是，我们今天时间不够，要开始。
因为敏迪一早来，然后跟我们聊了1个小时，然后给我们看一些奇怪的影片，然后就想说你们要开始，你知道今天很赶吗？
给我看影片的时候，我还跟他说拜托我们到店面去，因为
对，这影片有点奇怪。
很怕我被员工告。
Okay, that's all for me today. Thank you for your attention.